Welcome, my dear students. Today we are going to start a new week, sixth week basically, and the first lecture. And in these, five lecture, we are going to deliberate mostly on your solid waste, right? We have seen in our previous week that how agricultural waste can be converted to useful resources. And this week we are going to give more emphasis on solid waste. And we will also have a look at particularly your plastic waste as well, and what are the the laws governing this particular waste. We will also have a look. And once we are going through this solid waste, definitely we understand that due to this particular bargoing population, and which is enhancing or increasing exponentially across different continents, as well as particularly with reference to India, definitely we have increased this particular population immensely, and even within India also across different states, across different towns or cities, definitely that has been exhibited. So in this particular lecture today, we are going to see that how this is going to be very important, and how this particular population, huge population is, once you have huge population, definitely it is going to generate waste. So it is our concern now, and we have to have some sort of rational solution as well. So in this particular lecture, as I was mentioning, definitely we will be looking at different waste energy approaches from solid waste, an overview will be given, as well as plastic waste management and the governing rules, that also we will be taking care of. So one thing which I initially mentioned, that due to this rapid expansion of your industrialization, whether you call it urbanization, and evolving lifestyle pattern associated with economic growth, that has led to generation of increasing amount of waste. And these particular waste, once you are producing this huge amount of waste, this is going to pose or create significant environmental challenges if we do not handle it properly. So this is one concern is always there, that we understand by this time. The second thing is, in recent years, these advancement in technology also have enabled the generation of this decentralized energy while simultaneously reducing your waste volumes for safer disposal. That has also been happen, and that also we have seen that particular part as well, that the advancement, how those advancement and how innovation in that particular sector has changed this particular scenario. So definitely in this particular scenario, when we talk about technology and when we talk about this huge amount of waste, so definitely we need to have that sort of formula, or we need to have that sort of solution for waste to energy. And these waste to energy, once we are capable to make this sort of conversion properly, that is encompasses a range of processes that transform waste materials into usable energy, such as electricity or heat, that we have seen. As I was mentioning about that particular the way the population has increased, if you look at the population, and this is this is increasing like anything. If you look at the yearly change, the change, although very recently that change is a bit declined, but if you look at the urban population, this urban population is always increasing. That means because of just migration of population from rural areas to your urban area, as well as due to industrialization, definitely you have a huge traffic, particularly in urban areas. So that has changed, and that has increased like anything. And if we see in the last few years, the 25, so this is going to give you some idea about the 25 cities with the highest population density in the world. And if you look at these, definitely you will be able to see that once you have Manila in the list, at the same time you have Mumbai also in the list, right. So that means if you talk about those population density, definitely, and at the same time you have Kolkata is also there in the list. That means you have a huge population, that means you most likely we are going to produce more amount of waste material, or waste is going to be generated more. And now if we give that emphasis particularly from waste to energy, definitely what are the consequences? Because if we are capable to convert this waste to energy, some useful component, so definitely we are going to reduce our waste, that means waste reduction is possible, and this is going to minimize your landfill dependency and mitigates your waste accumulation, because this is sometimes creates visual pollution as well. So if you are capable to reduce this waste, definitely you are going to make that particular landfill dependency minimized, as well as it is going to mitigate your waste accumulation. The second most important part, which is associated with this, because as I was mentioning waste to energy, so that means you are going to generate energy. So that means it is going to convert non-recyclable waste into a valuable energy resource or source. And then greenhouse gas reduction, definitely it is going to contribute to your sustainability issues. It is going to contribute to addressing the climate change issues. So that means it reduces methane emission from landfills, because where it is going to be dumped, definitely it is a huge reservoir of your methane. So if we are capable to reduce that, definitely it will be a win-win situation. As well as from these waste material, we can recover some of your resources, and these resources particularly extracts valuable materials, mostly your metals, from these waste streams, and that can be reused, right, that can be recycled. And sustainable waste management aligns with circular economy principles, which actually believe on that particular principle of reduce, reuse and recycle. Definitely it will take care this component as well. So these are basically those particular, if we look at the importance of this particular waste to energy concept, right. And now once we talk about that particular solid waste, definitely you will have a number of wastes are involved in it, and diversity of wastes are being included in it. So various types of wastes are generated from daily human activities, right, and industrial processes, including organic waste, including your e-waste, as well as hazardous waste and inert waste as well. So segregation is always going to be a very, very important component, because once you have that sort of mixing, you have because as I said, it's a mixture, various types of wastes are involved in it, this is going to be a huge challenge. And once we talk about, because once you are going to segregate it in organic or those particular inert waste, definitely organic waste basically consists of material that decompose naturally over time through your microbial mediation. That means microbial activity is going to be very, very important. You need some sort of conditions that has to be imposed, whether it is with reference to your temperature or moisture, that has to be taken care of. Otherwise these particular organic wastes can be easily handled, as well as it can be converted to those particular useful materials. So these are basically those material, organic waste are those materials that decompose naturally. All organic wastes are primarily carbon based compounds, and though they vary in composition and degradation rates, definitely based on their profile of your, whether you talk about cellulose, hemicellulose, lignin, their decomposition rate is going to vary. Organic waste constitutes a significant proportion of your total waste in industrial, urban and agricultural sectors, that we have seen. And particularly whenever we talk about this particular solid waste, and particularly the urban waste, this is going to be a huge part, is going to be covered by this part. So due to its abundance, organic waste basically holds potential for energy conversion. The only thing which is needed, the segregation part. If we are able to segregate this particular waste properly or efficiently, So we will be able to do it. You can see over here there are multiple, when I was talking about those waste material. So there are, it's a mixture, as I was mentioning, whether you talk about organic waste, whether you talk about, EU waste, you can see over here. At the same time, there are many hazardous waste also related to some battery or those particular electronic material, as well as inert wastes are also there, right. These organic fractions, because we are giving more emphasis on this particular organic fraction where those microbial mediation is possible. So this organic fraction of waste is further classified into biodegradable and non-biodegradable fraction. So we need to have definitive strategies for both of them. So if it is a biodegradable waste which includes organic materials that can be broken down by naturally occurring microorganisms, either you through the process, basically they call it bio-augmentation, right. So if we augment that population of those microflora and microfauna, definitely within a reasonable time frame we can decompose that. So this category comprises agro residue, food processing waste, municipal solid waste, particularly food scraps, garden leaves, paper, cloth, rags, and waste from poultry farm, cattle farm, slaughterhouses, dairies, sugar mill, distilleries, paper mills, oil extraction plants, starch processing units, and leather industries. So, and this is a huge reservoir of multiple macro and micronutrients as well. But it has a chance of entry of some of your heavy metal and metalloids also, particularly from those leather or tanning industry, or maybe some of your paper mills or distilleries, they may contain some of your heavy metal and metalloids. But apart from that, in most of the cases, you are likely to get most of your macro, secondary and micronutrients out of it. The second is, as I said, non-biodegradable organic waste. So this is consisting of your materials that are highly resistant to biological degradation or decompose at an extremely slow rate. That means, you need more time. When it is possible, particularly for biodegradable part, to convert it to usable resources, maybe in 20 days, 25 days, 45 days, and this mediation, as I was mentioning it's dependent on use of consortia. If you are using a consortia, proper consortia, definitely this is going to speed up. So example include your woody plants, definitely having a high CN ratio, cardboard, cartoons, containers, wrapping, pouches, discarded clothings, wooden furniture, agriculture dry waste, baggage and rice husk. These are, as I mentioned in some of my other classes, that if it is having a high CN ratio, definitely it is going to make this process retarded, means you have the efficiency of that conversion is getting slower. So these particular, whether we talk about this in a mass, urban and industrial waste, they hold a significant energy potential. If we are capable to manage them efficiently, definitely we can convert them to your useful resources. Now I am going to expose you with those particular statistics where you will be able to understand what is the potential of those particular definitive components within this particular category of your urban and industrial waste. Look at this. This is basically your sector wise focusing on the energy potential for urban and industrial sectors, because the amount of waste material they generate and the potential they have, if we have a clear picture of it, definitely we can design it more rationally. If we look at this particular table, you can see that urban solid waste is always going to be at the top, almost it has a capacity almost to produce 1247 megawatt. You have urban liquid waste also. It has also a very good capacity, paper, liquid waste. You can see the other waste material as well, whether it is vegetable processing, vegetable raw, whether it is fruit processing, whether it is processing and preserving of fish, So these are always going to give you that much of energy, or this has that much of potential. If we look at the other component in it, particularly your fruit raw, particularly as a solid waste, it has also good capacity of your energy potential. You have your well seed or well yielding crops, particularly solid waste related to your palm oil, milk processing, right, maize starch, milk processing and dairy products, particularly liquid waste, and then maize starch, liquid waste. You can see all these lists from where you will be able to make some understanding that what is the potential, because once we can segregate that what are those definitive sources from where these wastes are being generated and what is the quantity, quantification is also very much important, because this, if we are able to make this sort of making a inventory of these waste generated, definitely we will be able to work out with their potential, because if we know that this much is having the capacity to produce this much of amount of your energy. We can also see it's a good distillery liquid waste, they have a huge resources, or they have a huge potential for producing your energy potential, particularly 781 megawatt. Also your slaughterhouse, particularly slaughterhouse, cattle farm solid waste and poultry solid waste, they have this all capacity. So in total, if we look at all these, definitely it's a huge amount. So these waste, the point which I am trying to put over here is, so we have a huge potential of resources where from we can convert those material, those biomass material, or whether it is organic waste or whether it is a solid waste, to your useful component in the form of energy, and this has this huge potential. It is having that sort of potential is have. In the last deliberation, or in the last slide, when I was trying to figure it out, those definitive components of those particular waste having that particular potential, we have seen that particularly if you remember that your urban solid and liquid waste, they contribute a huge amount. So now if we look at this particular, basically municipal solid waste is going to cover most of them. But at the same time I mentioned that segregation is always going to be a very important challenge. What needs to be done is we need to segregate first all of them, and once you do that, that particular storage and do that segregation, we need to make that sort of process start, particularly for making separation of those inert material, right? And once you talk about those recyclable, that what is possible, that whether some of them can be put into use again, particularly with ferrous and non-ferrous metal and plastics, particularly cans, tins, whether it can be put into use again, right? And if it is a broken glass, definitely or containers or bottles or cup, etc. So this can be always used in ceramics and those concrete and aggregates and recycled glass countertops, right? And if you have that sort of organic waste material, I was talking about those particular organics, this is hydrocarbon material, and there again, once we go ahead for your next group of strategy, definitely we have to look into your whether it falls under your high moisture biodegradables or whether it falls under low moisture organics particularly. So if it is a kitchen waste material, definitely it is going to contain high moisture content, but if it is a low moisture organics, particularly with reference to your polythene, your rubber, tire, etc. So for that also things are possible, particularly we mentioned that process of gasification, the process of pyrolysis, right, incineration. So this is and combustion, through this particular process we can achieve, or we can produce those sort of either in form of oil, bio-oil, or maybe biochar, or maybe ash. So this is possible, and ultimately we can convert them into some useful resources. And once you are dealing with, particularly with those sort of material, which is basically, as I was mentioning, those high moisture biodegradables. So there I was emphasizing on the last class about those anaerobic digestion. So always anaerobic digestion can be facilitated, and once you go ahead with this anaerobic digestion, definitely you can get a huge amount of biogas, as well as your digestate will be there, and that digestate is an excellent resource, particularly for as a fertilizing, because it has a very good fertilizing value, having NPK, means most of your macronutrients as well as some of your secondary nutrients and micronutrients. So that can be used as a fertilizer, and that can be used as a soil conditioner as well. And this particular when I was talking about the other part of it, means if you are using anaerobic digestion, definitely you will be able to work out with your organic compounds, and those organic compounds are going to be used multiply for multiple reasons, maybe as I was mentioning, giving stress on your biogas, particularly with reference to your methane, and at the same time also methanol we also produce during your anaerobic digestion, right. This can be used particularly when we started initially. We have a multiple segmented waste material, and when if we are able to segment them in proper context, definitely either they can be used or they can be recycled or they can be reused also, and we will be able to convert them into some useful material. That we have seen from these particular resources, that how these waste material or how this waste is going to be, particularly solid waste, is going to be very, very important resource for your energy conversion. So this is an example of United States of America, because once you are producing your waste material, whether that whole waste is being converted to some useful resources or some of those waste is still being left, right. So that I have shown in 5th week, that still there are few cases that there are few unused resources are there, unused, those particular I am talking about those waste material. So if you see through this particular diagram, there you will be able to see that what is the total municipal solid waste generated and how they manage, and the full of it is being managed. If you look at, there are multiple segmented, whether it is coming from glass, whether it is coming from wood or rubber, leather, textile. So these are those definitive solid waste which is being generated, and at the same time you can see over here that yes, what are those use they have done with those particular waste which is being generated. So most of it is being landfilled, right. Most, half of it is being landfilled, 1/4 of it is being recycled, and then as I said that almost 12% is being burned for your energy recovery, what I was mentioning particularly with reference to your gasification and pyrolysis. So this is being done very efficiently, and then composted, means I was talking about those composting, and these are very few resources which is being either not being used properly or it is used for some other reasons or other segments. So the point which I am trying to emphasize over here is, whatever amount of waste is being generated, almost you can see over here, almost 95% is being used in different segments and properly. That means that energy auditing or that particular auditing is possible, and that is you can see over here that what is the total generation of your the solid waste and what is being used, and 12% of this 292 million tons of this waste which is being produced was processed in waste to energy plants. So this is very important component. The other component is that annual electricity generation from these particular municipal solid waste plants. We have seen that most of it used particularly is for your landfill, part of it is being recycled, part of it is being composted, and part of it is being burned for your energy recovery. And particularly if we take it in terms of your electricity the generation, if we look at this, that yes, starting from 2012 to 2022, we have those particular segmented part of non-biogenic and biogenic resources. So this biogenic particular material, and you can see over here the non-biogenic segment is increasing as we move forward from 2012 to 2022. So, and the biogenic material which contains basically packaging, paper, ear trimmings, food waste and textile, etc. This is almost constant or it is getting decreased. So the part which is very important is a considerable amount of electricity is being generated particularly from municipal solid waste plants particularly. So in this context, there are few countries who has done remarkably well, particularly if we take the example of Japan. If we take example of, South Korea, they have done tremendously, good work, particularly with conversion of this waste to energy sort of interventions or initiatives. And India is also, trying to make its own impact particularly. And this is going to give you some idea that this percentage share of this, this solid waste which is being burned with energy recovery in selected countries. India is not there in the list. You can see over here, Japan has done tremendous, very good work. Even United States is only, 12% you can see over here. And Japan, I have given the example of Japan, but, India is nowhere. So the point is, these particular, and even, some of your Scandinavian countries or as well as Switzerland, Belgium and United Kingdom, they have also done pretty good work, particularly with reference to converting this particular waste to energy, right. So now the thing is, what I was mentioning, the percentage share of particularly municipal solid waste burned with energy recovery in India is relatively low, or either it was not there in that particular slide. So that is impliable that, well, we are not in a position to do it in a very considerable, segment. So, but definitely India is trying to develop and trying to, reinforce in this sector and trying for many more innovations. So India is still developing its waste to energy infrastructure, and a significant portion of this particular solid waste is managed through landfills or open dumping, because most of it, because in case of United States you have seen half of it is being, and particularly for India most of it, almost 70 to 80% is being, used particularly for your landfills and open dumping. And if you look at within India, because I said India is also trying to figure it out in that particular statistics. So definitely you can see over here that, yes, what is that particular state and what is their potential. That means I am talking about the recovery of electrical energy from this municipal solid waste. So Andhra Pradesh is, heading, Maharashtra is also doing very good, Tamil Nadu is also doing, and Delhi and this Andhra Pradesh, particularly among the states, Maharashtra is heading that particular list. And there are, other states, even you can see from here that states from northeast, they are also, coming up with this particular sort of intervention of making this waste to energy, this particular component, right. So in this lecture, what we have, or in this particular class, what we have tried to find it out that, well, solid waste is coming up, and this is becoming a huge issue, particularly for the developing world and also including India as well, because, as we looked into that, yes, there is a huge burgeoning population, and once we have a huge burgeoning population, definitely we are, creating or generating a huge amount of waste material. So definitely these waste has to be, streamlined into some components so that it can be converted to some useful component. And mostly now, people are looking into those particular generating electricity. I have given that component. Even, United States, although they have that sort of infrastructure, although they have that sort of, but they have that sort of auditing mechanism of those amount which is being used, and they have that particular, resources or that data which actually enable them to make those sort of strategies. And even if, although they have those strategies, but still only to the tune of 12% is only, converted to electricity compared to, Japan. So India is also trying to come up in this particular category and trying to figure it out to make a huge contribution, particularly because, if a sizable contribution is being made, particularly from these, solid waste, particularly to your electricity, definitely it will be a very, very good contribution. So with this, I am going to end up for today's lecture. So in the next, few classes, we will likely to see the other components of this solid waste and how it is going to impact us and how we can, convert it and what are those issues. Thank you very much.